All right, so now that we have the unit circle, which we have here as a reference, what we'd like to do is evaluate some trig functions. So now that we've got this layout, let's put it to work. I'm just going to have to kind of slide back and forth between these. There's not really a good way to have them both on the screen at the same time, so that's okay. And so in theory, now that we have this, all these things should go pretty fast. You can kind of remember, in theory, sort of what we were trying to do, all the work we needed to do to find a reference angle, identify the quadrant, draw the special triangle, right? There was sort of a lot of stuff that went into finding these values at the end of 5.3. If we have this sort of unit circle as a reference, this should go really fast. So all we're going to do here is say, okay, so sine at 135. So this should be the y coordinate at 135 degrees. So all I'm going to do is back to the unit circle. Where's 135 degrees, right? Halfway between 90 and 180 would be here. On the unit circle, x and y, sine value is supposed to be the y coordinate, so it's going to be root 2 over 2, positive root 2 over 2. So that's all I'm doing. So once I have this as a reference, I can sort of get to that value very fast. Let's keep going. Let's do cosine at 7 pi over 6. So what's that going to be? So cosine is supposed to be the x coordinate. So at 7 pi over 6. 7 pi over 6 would be 210, but we have both radians sort of and degrees on our unit circle, so we can use that as a reference. 7 pi over 6, right? Bigger than 1 pi, less than 1.5 pi. It's here at 210. We're doing cosine this time, so our xy coordinate, negative root 3 over 2, negative 1 over 2. What I'm after is the x value. The x coordinate is cosine, so it's just going to be negative root 2, negative root 3 over 2. Bam. Super fast. What about something like a tangent? So we said tangent, I don't know, let's do tangent at 240 degrees. So tangent is supposed to be the y value divided by the x. So what I'm going to have to do here is maybe just a little bit more work, right? So it's not just pulling sort of one coordinate out. I'm going to have to take both the x and the y coordinate and then stack them, the y value over the x. This is 240 for us, right, on the circle. Down here, right, 4 pi over 3, 240 degrees, almost to 270. So tangent is the y value divided by the x value. So for us, that's going to be, you can see it here, right? So this is going to give us a little fraction stack. So negative root 3 over 2, that's the y coordinate, over negative 1/2. Okay, like that's not wonderful looking. In theory, a special triangle, right, would maybe get us a little bit of a cleaner answer. But a couple things that will happen. One, negative over negative, this is obviously going to be a positive, right? Double negatives will cancel. And then what I'm doing here is I'm just going to flip and multiply. And so when I do that, you'll notice on the unit circle, the denominators on all of these fraction coordinates, right, all the fraction x and y values, the denominator in every single one is 2. So it's something over 2, root 2 over 2, 1 over 2, right, 3 over 2. Everything is something over 2. And so what that means is whenever I do a tangent or a cotangent and I start to stack these guys together, when I flip and multiply, the two denominators are going to wipe each other out. So this is negative over negative is positive. This is root 3 over 2 times 2 over 1. 2 cancels 2. So this is just positive root 3 over 1, which would be positive root 3. So a little bit more work there, right, working with a tangent function, but not an unreasonable amount of work. And in some sense, once we know that the denominators are going to cancel in this way, it speeds the process along a little bit. Let's do a cotangent. How about cotangent at, sure, 7 pi over 4. So cotangent is supposed to be the reciprocal for tangent, so that's the x value over the y value. 7 pi over 4. Kind of get these guys so you can see them both. 7 pi over 4 is here in quadrant 4, right? So it's the x coordinate divided by the y coordinate. So that's positive root 2 over 2 divided by negative root 2 over 2. Couple things. At 45 degrees, right, the x and the y values, because the sort of legs on the triangle are the same, the x and y coordinates are the same. So even without getting into the weeds in this, I mean, sure, if I wanted to, I could sort of flip it. Root 2 over 2 times, right, negative 2 over root 2. But like everything here is just going to cancel, right? The idea here is these really are the same value. One is positive, one is negative. So I'm just going to be left with a negative one. And that'll be that. So at the 45s, because the x and y coordinates are the same digits, they'll cancel down to 1. It's just a matter of getting either a positive or a negative version of it. A couple more things that can help us. If you have negative angles, there's a couple properties we can use. So obviously the unit circle is great for angles that are between 0 and 360, but we're going to have to deal with negative angles or sort of bigger angles at some point. So if you have a negative angle, some sort of negative between 0 and negative 360, a couple things to keep in mind. So sine theta and tangent of theta are what we call odd functions. And so what that means is if I do the sine of a negative angle, what I'm just going to get back is the negative version of sine at the angle. And then the same thing for tangent. So if I do a negative angle, I just get a negative version of what I would have gotten for the positive angle. So for example, right, if I wanted to know something like what is the sine value at negative 3 pi over 4. So this property says, I mean, you can do a sketch, right? You can figure out where in the circle that lies, but the maybe even faster version is just say that should just be the negative version of the sine at positive 3 pi over 4, right? It's just going to be the negative version of that value. And again, if we sort of use our circle as a reference, 3 pi over 4, right? It's up in quadrant 2. This was the sine function, right? So that's going to be the y value. So at 3 pi over 2, the y value is root 2 over 2. So this is going to equal the negative version of root 2 over 2. And then a similar type of thing for tangent, right? Tangent's going to have this exact same property. So I can get a negative angle pretty fast by you know, for sine and tangent, just taking the negative version of what I would have gotten for the positive. Cosine of theta is what we call an even function, and so that has the opposite property. So if I do cosine of a negative angle, what happens is I'm just going to get back cosine of the positive angle. So a negative angle versus a positive angle for cosine, and you can kind of visualize why this is happening. The value here is going to stay the same, and that's because in our circle, right, so for the sine function, sine values are based on y coordinates. So if you're doing sort of a positive versus a negative rotation, right, the y values are sort of positive and negative versions of the same coordinates. But if you do the same thing for the x values, which would be our cosine values, the x values, right, quadrant 1 and quadrant 4, the x values are totally in sync. And then they switch to negatives, right, quadrant 2 and quadrant 3, they meet and then they flip, and so on and so forth. So cosine has the sort of opposite property, where if I throw a negative in front of a cosine angle, I just sort of get back what I would have had for cosine of the positive version of the angle. So for example, right, what is cosine at negative 300 degrees? So what this says is it should just be equal to the cosine at positive 300. I'm just going to look at positive 300, just get my cosine straight from there, and I'm not going to change a thing. 300 for us is here. Cosine is the x value, so that would be for us positive 1/2. Done and done. If we are working with larger angles, right, the sort of short version is just find a coterminal between 0 and 360. And it's really as simple as that. For larger angles, so just find and use a coterminal. And I'm not writing it out, but I guess sort of implied in this statement is a coterminal between 0 and 360, right? A coterminal between 0 and 2 pi, a coterminal on the unit circle. So let's say, for example, we wanted to find, let's do the tangent at 480 degrees. So you say, okay, that's obviously bigger than 360. So just take a minute, find a coterminal. So we'll just do 40. We'll just subtract the 360 off of it. What's this going to leave us with? 120. So if we end up in that same position, obviously our sort of trig value, our tangent value is just going to be the same, right? We're going to be left in the exact same position. We're just taking off a rotation. But we're going to end up at the same kind of xy coordinate, and from there we can just sort of do our tangent value accordingly. 120, where is that? 120 is here. Tangent is supposed to be what? Oh, look at that. This is supposed to be positive, right? Positive y. I think everything else is okay. So tangent should be root 3 over 2 over negative 1/2. So I'm just going to take, so negative root 3 over 2, divide by 1/2, running out of space a little bit. Flip and cancel, 2 cancels 2. So that's negative root 3 over 1, which would just be negative root 3. So, they haven't made an angle big enough to stop us yet. So we can do this for any kind of coterminal, regardless of how big it is. We just got to subtract the rotations off until we get something between 0 and 360. So using the unit circle, that's the plan. Great tool, right? It sort of takes all this build up to really get us there. We can't just jump right into it. We need to sort of figure out how it works and where all these things come from. But once we know, once we have it, it's a great tool. We're able to sort of get all of our information from it pretty quickly, and we're good to go.